In this lecture, we shall learn that how we can design the C purlins that we do install on the top of the footer bridge to support a timber deck. So let us suppose that we need to proceed with the exacta C purlins, and number of spans we can select it as, let us say, 3, and each span is having we can say 2000 as the number of spans are typical, so we don't need to worry about the complete length. And in this we can select and find purlin size, and we cannot assume any kind of restraint from the sheeting attached to the purlin, because ultimately we are having the timber decks on the top. So we can select a default bridge spacing, and we can left click on continue to adding load cases. So under the first primary load case, we can name it as the, we can say, dead load, and we can click on the new load option, and the second case we can select as the live load option. So ultimately now we are having dead load and live load. So after that we can click on the dead load option to add the load here. So we can click on new load option here, we can click on UDL, and the spacing, as we know that our complete span is 2000 So we can assume the purlins to be spaced at 250 center to center spacing. So let us assume that this is our typical span, and in this we are having the closely spaced purlins at 250 center to center spacing. So let us assume the dead load we are having is approximately 100 kg per meter square, or we can say 1 kN per meter square. Live load we are having is, let us say, approximately 5 kilonewton per meter square. So the UDL which needs to be applied for the dead load is equal to 1 into 0.25, that is 0.25 kilonewton per meter. And if we're talking about the live load, that is nothing but 5 into 0.25, that is 1.25 kilonewton per meter. So we do need to apply the dead load of 0.25 kN per meter and live load of 1.25 kN per meter. So under the dead load option, we can add 0.25, and we can click on all spans here, UDL, unit kN per meter, and we can click on new load option here. Yeah, so now a 0.25 kN per meter load is applied on all the spans. And if we're talking about the live load, similarly we can click on new load option. Again, we can add UDL of 1.25 kilonewton per running meter and click on all spans. After that, we can click on combined load cases. So we can click on new CLC with strength only. We can click on add load, and factor here can be 1.35 times the dead load. And this we can delete it as of now. And after that, the second can be like 1.2 times dead load and 1.5 times live load. Sorry, we don't need to delete this. Now 1.35 dead load is okay. And after that, we can click on again new CLC. We can rename this as 1.35 times dead load. And the second one we can rename as 1.2 times dead load plus 1.5 times live load. And this we can add here 1.2 times dead load and 1.5 times of live load. So now this is also okay. So 1.35 times dead load, 1.2 dead load plus 1.5 times live load, and we can click on serviceability and we can click on new CLC. This shall be nothing but 1.0 times dead load plus 1.0 times live load. So we can add both of these factors here. Sorry, we do need to remove the factor. Here we can take it as 1. So one time dead load plus 1 times live load. So now the load combinations have also been applied. And deflection limit, this is strength only, this is strength only, and this is serviceability. And we can assume that deflection limit we can keep it as, let us say, span by 250. So we can click on choose load case for analysis and design. We can keep all the load combinations here, and then we can left click on OK here, and then we can click on calculate. So we can click on the moment capacity design to find the purlin sizes. So here we can see that the purlin sizes that are passing in the design is C purlin of 150 by we can say 1 mm thickness. And we can click on the shear force diagram also. So we can, if we are checking one solution, so EC 15010 Perlin is okay as per the design requirement. And we can click on show design results to find out the result summary. So here we can see that EC 15010 Perlin is passing with very nominal utilization in the case of the combination also, and in the case of the serviceability also. Serviceability also, deflection ratio is only 0.11. So as of now, we are safe and we can proceed with C purlin of 150 mm depth and 1 mm thickness. So we can save this file here by clicking on save. So now we can proceed with the modeling in the ETAP software by just keeping this EC 15010 in our ETAPs and not designing that. We won't design that. And one more thing that we can do here is that we can click on return to editing spans, and we can click on continue to adding load cases. In here, what we can do is that we can increase the value. So let us assume that instead of 250 mm, let us say we want to proceed with 500 mm spacing of the purlins. So we can do that also. So dead load, we can just simply double the UDL that is acting, and live load also we can just simply double the UDL that is acting, that is 2.5. So dead load is, we can say 0.5 and live load is 2.5. So we can click on the calculate option here, and after we can click on the moment capacity design. So instead of again, we can see here that EC 15010 is passing even with the 500 mm center to center spacing. So we can proceed with EC 15010. There is no as such requirement to have the spacing of 250 mm center to center spacing. We can increase the spacing to 500 mm center to center spacing also. So with this, I hope the system is clear to you that how you can design the C purlins with the UDL that is acting from the superstructure.